13%. 13%. Yeah. But I want to explain a little bit. The answer is B. I still want to explain a little bit because in class, when I explain this concept, this one, a diabatic condition, when I explain this one, I didn't explain clearly. Yeah. So now I want to use this chance to explain this concept another time. All right. So I just copy the, related definition or description about this concept here. Yeah. So let me try to this time explain it clearly. Yeah. All right. All right. This condition, yeah. So bar under diabatic conditions, no heat exchange with the neighborhood. Okay? Yeah. Neighborhood around that bar. Yeah. So here we assume we have a heated bar. Here, this bar. Okay. All right. Yeah. Very hot. Yeah. Then neighborhood, right? Yeah. So around it. Yeah. All right. So the condition is no heated exchange around, with the neighborhood environment. Assumption, the bar is completely insulated. Yeah, same thing, right? Insulated, no heat exchange, same thing. Also at the ends. So here, definitely include the ends, right? Two ends, including the no heat exchange at the ends, because we need our boundary condition at the ends, two ends. Okay, all right. Then, physical information. The heat flux at the ends is proportional to the value of partial derivative at the ends. Yeah, so that's partial derivative. Yeah. So based on the physical property, so that heat exchange, heat flux, flux exchange, right? Yeah. Heat flux, heat exchange, at the ends is proportional to the partial derivative at the two ends. All right. Then, no heat exchange means the value, partial derivative value at the two ends must be zero, right? Yeah, that's the meaning. So the partial derivative to be zero at the ends, not the function values to be zero at the ends. So the first boundary condition is the function value. The function value the W function, do we mean the temperature, right? W function, the temperature of the bar, okay? Yeah, so the temperature value to be zero at the ends, that's different from derivative to be zero at the ends. Yeah, because we do not require, for this condition, we do not require the temperature of the bar at the two ends to be zero. Yeah? The temperature at the two ends could be still very hot, but no heat exchange. Yeah. Things like that. Yeah. All right. So that's the, because people we may get confused with the temperature and the derivative of the temperature. All right. All right, so that's just the concept. All right, all right. So now we finish this quick quiz 2, concept questions. Yeah.
Did you say we have access to the slides during the midterm?
Sorry?
Did you have access to the slides?
Yeah, definitely. Yeah. Open notes, all the materials of this class open. Yeah. Yeah. You know. Yeah. Yeah. I will talk about that. Yeah. So in the when I give you sample questions, I will further explain. Yeah. You can use your laptops in the test. Yeah. Yeah. But I need to. Here we have online, midterm online, final in person. The rules slightly different. Online, the rules same as your homework rules, right? So when you do a regular homework assignments, you can use a lot of things because I do not give you restrictions, right? Yeah. So that's same rules apply to midterm. But online, when you sit here, yeah, some rules we need to do slightly different. You can still use, all the course materials. Other than that, you can use laptops to access online calculators. Wolfram Alpha, for example, you can use powerful calculators to save your time, because a lot of calculation could be very complicated. Derivatives, for example, very time consuming, so you can use Wolfram Alpha to calculate derivatives. Yeah. So in the final, you can do it. You can use that. Yeah. But when you use laptops, you cannot use search engine, AI tools, yeah, communication software. Those things are not allowed in this in-person test. Yeah. All right. Question types with sample questions. Yeah. So each type, I give you one sample question. Yeah. Sample question, that means the real question will be very similar to the sample question. Very similar to the sample question. Yeah. So I try to make the midterm not too hard for you. Yeah. Yeah. To be realistic, reasonable. Yeah. Not too hard for you. All right. All right. The first two questions. Yeah. Module 1, Part A, I pick one question. Okay? So this uranium question. Yeah. Half-life, right? Yeah. So here, the sample question, the real question I plan to give you, I will use the same context as the sample question, but I will modify the condition slightly. Yeah. So it's a non-trivial modification. Okay? It's a non-trivial modification. It will not be a trivial modification, right? So what's the trivial modification? For example, I change this to 15%. Right? That kind of modification is the trivial modification. So you won't have that kind of trivial modification. Non-trivial modification. So you really need to work on it a little bit. Okay? Yeah. Yeah. All right. So that's the first question. Yeah. Yeah. So that's the Module 1 Part A. Yeah. Module 1 Part B, I select exercise, set 2, question number 2. Okay? Yeah. So this one, I post the solution, right? Yeah, I give you the solution to the exercise. You can study that solution. Yeah. So the real question, I plan to give you same context, right? Same context. Yeah. But I will modify the conditions. So the condition part, I will change slightly. Yeah. But definitely when you solve it, you need to make adaptation. Yeah. So there is a older solution. So definitely you need to change based on the non-trivial modification. Yeah. How to handle the different conditions. Yeah. Same context. Yeah. All right. Yeah. So that's the first two questions. Next two questions. The third one. Yeah. So this, directional derivative, right? Yeah. In our homework assignment question. Yeah. All right. Yeah. Yeah. So the same context, but I need to modify slightly. Okay. Yeah. So if we are familiar with the directional derivative, yeah. So then you can still use that method, directional derivative. All right. Yeah. Because when I did grading, I didn't see many students use the interpolation, linear interpolation way to solve. Yeah. No problem. No problem. Yeah. But I will modify the condition slightly. I will still do non-trivial modification. Yeah. Same context. Yeah. So I will make non-trivial modification. Ask you, still calculate rate of the temperature changing. Yeah. But I will ask you calculate the rate of temperature changing at a different point. So here we need to calculate at this point, right? Yeah. How about I ask you calculate the temperature rate of change of the temperature at a different point? That's the way I will make the change. Okay? That's the way I will make the change. Okay? Yeah? Yeah. So just give you an idea. Yeah. So how much I will do the change, I will modify the sample question. Yeah. So when I make my midterm question, I haven't started. Yeah. So I will make those 10 questions tomorrow. Because tomorrow I will have another midterm for my AMSO class, algorithm class. So I need to first take care of that midterm. So after I assign midterm to my AMSO class, then I need to work on your midterm. So tomorrow after my evening class, then I need to work on your midterm questions. Okay? Basically, I just modify each sample question. Okay? Yeah. So I copy the original sample question. Then I change part of the conditions. Things like that. Okay? Yeah. Yeah. So in that way, you will not get big surprise, right? Yeah. So all the questions, you're familiar with. Yeah. But definitely, you need to do some non-trivial work. Yeah. Yeah. But the condition will be different. Yeah. All right. Yeah. This question. Yeah. This question. Yeah. I modify the condition slightly. Yeah. Okay. 2 ODEs, right? Yeah. 2 ODEs. Yeah. In 2 different periods. Yeah. Fission period, no fission period. Yeah. 2 different ODEs you need to solve. Yeah. All right. Then there is fish catching constant H, right? For fish catching fish, yeah, there is a H constant. how much amount of fish are allowed to be caught, right? Yeah, H constant determines amount of fish allowed to be caught, okay? Now, so then I may adjust this H values, okay? Now, it's not a big change, H value. Now, so people can measure amount of fish in the, where is it? Lake or, pond, lake, whatever it is. Yeah. When people measure the amount of fish is above certain line, okay? Yeah. So there is some, equilibrium line, some line people need to control. If the amount of fish higher, significantly higher than that line, then H number should be larger, right? Yeah. People, catch more fish. Yeah. When the line below this line significantly, so there you need to, make fish grow more, right? So you need to adjust this H value to be smaller, so making fish grow faster. So thinking about that kind of modification, H1, H2. So I will give you two H values, 1 and 2, based on the amount of fish in the lake. All right. People can measure, use statistics, some scientific way to measure amount of fish in the lake. That kind of change. Okay. That kind of change, but the context is the same. All right. So that's the first 4 questions for module 1. Then next 6 questions for module 2. All right. Part A, 1 question. I need to give you 1 question. This reduction of order. The sample question, our first homework assignment question for second assignment. So you need to do reduction the technique. Okay. But after you apply that substitution, you may not get a separable equation immediately. So you will get an extended separable equation. You still need to do another round substitution to make it separable. This kind of question. The equation I will change. The idea the same. Same idea. All right. So that's the question number 5. So the whole idea, so when I make these 10 questions, the whole idea, I will control the level of difficulties. I will not make this midterm very difficult. I will not. So regarding the calculation, so I don't want you to use too much time to do the calculation. Basically, what I want to test you, if you know the techniques, because for different type of questions, so there are some appropriate techniques to be applied. So my main consideration is I want to check if you have mastered those techniques. For the computation part, I will make it easier than that of the homework assignment number 2. Homework assignment number 2, some of questions still a little complicated. So when I make question the formula, I will make sure the computation part you can use the Wolfram Alpha to do it, but even that, the computation part, simpler than the second homework assignment. Yeah, so quite reasonable. Yeah, quite reasonable, but you need to know all the main techniques. Yeah, first shifting theorem, second shifting theorem, and how to split the fractions. If you want to use partial fraction, that method, or use the decomposition way. In my solutions, I use quite a lot decomposition way. Yeah. So if you can understand, then you can use those way. Otherwise, you just use the partial fraction way. But those fractions, I will make sure not too complicated. Yeah. Just get to the point. So I need to check if you can apply those techniques. Yeah. Get to the point. Yeah. That should be good enough. Yeah. All right. Then this question, number 6. Yeah. So we know. Yeah. So in one of the exercise question, I gave you the detailed solution. So this one, the solution is similar to the exercise question. The solution quite similar. Yeah. 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 So this function is irrelevant, right? Irrelevant. So I make it very make it look very complicated, but in our calculation, cancel out. So irrelevant. We only need to make sure this is continuous. That's enough. This must be continuous. Then it's enough. Yeah. All right. So I will give you a question using the same context, but I will change slightly. Okay. Yeah. So my description, conditions, yeah. So I will make a slightly different story. Different story. Yeah. But the bottom line is the same. The fundamental part is the same. Okay? Yeah. Yeah. All right, so that's the question number 6. Yeah. All right. Then, next 2 questions. Yeah. Shifted data, yeah, you need to do one question on the shifted data. Yeah. Yeah. But the way you do it, I want to make the Laplace transform, inverse Laplace relatively easier. Yeah. Yeah. Easier than this one. Manageable. Yeah. So not too time consuming. Yeah. But you need to know the basic steps to calculate. Yeah. But the formulas, I will make it as simple as possible. Yeah. 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 That means I try to give you good numbers. Yeah. Not those ugly numbers. The numbers, so we'll as good as possible. Okay? Yeah. Because my purpose, I want to check you if you know the related techniques. Yeah, basic techniques. Yeah. Yeah. Not I don't want to test you on your computation skills. Yeah. Not that. Okay. Yeah. All right. So that's this question. Yeah. Then this question, yeah, because this question about the choice rules. Yeah. So I will select one ODE questions. Check your understanding on the choice rules. Yeah. Today I cannot explain. Yeah. But next class, yeah, all these related questions, I will use different topics. Okay. Choice rule, one topic. Okay. So then, reduction of orders, another topic. Laplace transform, another topic. Yeah. Yeah. So there are several topics. in our Thursday's class, I will, go through those related questions on the solutions. Yeah. All right. All right. So then the last two questions. Number 9. Yeah, you need to do one electric circuit. So here, RLC circuit. Yeah. 3 different types of components. Yeah. Yeah. All right. Yeah. And this one, yeah, because this one, the E function, is not a piecewise function. Yeah. So this one, you do not need to use Laplace transform. This one, yeah. This one, I give you, so you need to use that. So we have one similar example. Yeah. So my intention is, yeah, so it's better to use the method used in that reactance, right? Remember? So S, we calculate S, that's the reactance concept. Reactance concept. Okay. Then, so you calculate the particular solution, IP. IP, you have little a, yeah, because a cosine of this t plus b sine t. Yeah? Yeah. There is a formula A and for B. Yeah. You just write the formula, plug in numbers, you calculate it to do the calculation. Yeah. So this question is on that topic. Yeah. Very easy. But you need to know, that's the way to go. You need to know that. Yeah. Although, if some students like to use Laplace transform to do the calculation, still okay, but you will use more time, much more time. Because Laplace transform and inverse Laplace transform, a lot of time. Yeah. If you really like to go that way, it's okay. Yeah. But I think this method, if you just apply the formula, much easier. Yeah. Much faster. Yeah. All right. Then last question. Yeah. So the PDE question, yeah. So we need to do at least one PDE question, right? Yeah. So that's the reason. Yeah. And we need to do at least one PDE question. But for the PDE question, the one I gave you in the home assignment number 2, that's not suitable for Laplace transform. Yeah. Because on our textbook, so that question belongs to the Fourier series topic, not Laplace transform topic. Yeah. Yeah. Yeah, but we haven't learned Fourier series, so we cannot use Fourier series to solve that problem. So I give it as a Laplace transform. Then the last step, we cannot calculate. Too complicated. If we use Laplace transform, too complicated. So you skip the last step. We skip the last step. Yeah. But here, for the midterm question, then we need to complete the whole solution. We cannot skip last step. But here I give you this wave equation. Here is a double, second derivative, partial derivative. If we have second derivative, then we can calculate. Now, the reason is the first derivative, we cannot. The first derivative case would make the Laplace transform, inverse Laplace, extremely complicated. But second derivative make it inverse Laplace much easier. The reason is, because we will have S squared W equals partial In this case, there is x squared. Remember, we need to take square root. Then square root of s squared, then it's a good number, right? Yeah. So then we can do the inverse Laplace. But the first partial derivative, this case, too complicated, because this time we only have s, no square. Yeah. Inverse. This case we need to use square root of s. Then very ugly, you know. Remember, we do not have specific formula for inverse Laplace transform. No definition. Remember, no definition for inverse Laplace transform. Inverse, our formula for all the inverse version all come from direct Laplace transform version. We just reverse it. But there is no well-defined formula for inverse Laplace transform. But for the Fourier series, it's different. For the Fourier series, there is a clear definition. A clear formula, not definition, because inverse comes from the original transform. But there is a formula for inverse Fourier transform formula. But for Laplace transform, no explicit inverse Laplace transform formula. That's the reason. When the function not good enough, we cannot do the inverse Laplace transform. The function is too bad. Nobody knows how to do it. But even the function is very bad, because we have an inverse Fourier transform formula. We can write it out as an integral inverse. Integral, if we have the integral expression, the last thing we can do, we can apply numerical calculation, right? So for the integral calculation, we can use numerical approximation to calculate it. So we have a way to calculate it. But if you do not have the inverse transform formula, even if we want to use numerical calculation, we cannot. No formula, how can you do the numerical calculation? That's the key difference. So that's why solving partial differential equations, Fourier series, Fourier transform method, usually more powerful than the Laplace transform method. More powerful. Yeah. Because there is explicit inverse transform formula. So more powerful. Can do more. Can do more than Laplace transform. Yeah. All right. Yeah. So that's pretty much what I want to talk about in the review session number 1. Yeah. So review session number 2, then I will go through the details of the solutions. Yeah. So which part you need to, spend time to do preparation, the key part, the main part. Yeah. Yeah. So go through all the 10 questions. And the modification. Some question, I give you the idea. How do I plan to modify the questions? So let you have some mental preparation. Okay? So you need to think about this type of questions. All right? So, yeah. So Thursday, so we will talk about that details.